It is given that a metal bar of length L is covered with some non-conducting material to prevent heat loss from its surface, and two ends are maintained at a steady temperature of theta 1 and theta 2. In steady state temperature, theta of bar above the surrounding at a distance x from the hot end varies as shown in graph S. So we know that in case of conductor, when the heat flow is happening at a steady state, then temperature of each and every point on this conductor becomes constant, and we can find out the value of temperature at any point by using the concept of temperature gradient. So the temperature is gradually decreasing from its maximum value to its minimum value on the other end. As an example, let's say temperature of this side is 0 and temperature on this side is nothing but 100. So gradually the temperature will decrease, or linearly the temperature will decrease from 100 to 0 if you are moving from the hot end to cold end, in such a way that the value of its temperature gradient, the value of temperature gradient is equal to a constant, which is nothing but delta T, which is difference in temperature divided by length. So there will be a linear variation of temperature with respect to distance. So we can say that this B option it is correct.